to the Journey Shake Cam. I am so excited I can barely hide it. You know we're doing a lab today, so let's please do the warm-up questions as quickly as possible so we can get into the lab. Number 1 asks, what is a metathesis reaction? And this information is given in the discussion, and we need to read through the discussion because it gives some very important information. Well, a metathesis reaction is just a double displacement. It's just a fancy word for double displacement. And we have a double displacement in one of the reactions. Now, if you look at the very beginning of your lab, there are 5 reactions that are given to you. And we're going to discuss a little bit about those reactions before we begin the lab. Well, number 2 is asking for some of the terms to see if you understand them. And you know, it's always a good idea to look at a dictionary if you're not quite sure what the terms are. Well, one of the terms is to decant. Well, what does that mean? To decant means to pour off the liquid from the solid precipitate, and we'll be doing a lot of that. Then the supernatant is the liquid that we are pouring off of the solid precipitate. So pouring off the liquid is decanting, and what we pour off, that liquid, is the supernatant. And then what is washing the precipitate? Well, when we look at the reactions, initially what we're going to do is take the copper and add it to some concentrated nitric acid. And it is going to form this copper 2 nitrate, and we're going to see what else happens there. And then this copper 2 nitrate, we're going to add some sodium hydroxide and form this copper 2 hydroxide. This copper 2 hydroxide then will be heated up, and it will form this copper oxide. Well, there are 2 things that are formed here, and there may be some sodium nitrate ions that will attach to the solid, and we want to wash them off because we don't want them adding mass to our materials. And normally I grade this on accuracy, so depending upon how close and what % yield that we get will determine what percentage of that 20 points that we get on the lab. So hopefully we're going to do it very, very carefully. And that's what washing the precipitate is. We're taking the sodium and the nitrate ions that may adhere to this solid off of there, and we're cleaning it up because sodium nitrate is soluble in water, and therefore it will easily come out with the water as we're washing it. And you can see that water is our other product here. Then it also asks, what is evolution of a gas? Well, evolution of a gas means a gas is created. It is coming off of the reaction, and that would be this gas here that is going to come off of the reaction. So there is a gas definitely that will be arising. It's very exciting, and so I can't wait to see you in the lab. Let's go! Here we are in the lab. Oh my goodness, I'm so excited. Well, the first thing we have to do is weigh out 0.50 grams. Now, the lab may say 0.0000, but that would be in a college level class where we have an analytical scale. So what we're doing is we're only going to go to the 0.01 place, which is the hundredths place. And I have prepared this, so it should be exactly 0.50. There we go, 0.50 grams of the copper. And I will see you at the hood. Well, here we are at the hood. Now what the hood does is it sucks all the air out, and we have used this before in the lab. Well, it's very, very important in this portion of this lab. I have my piece of copper, and because I'm always in a hurry, I'm going to cut it into smaller pieces so that it reacts more quickly. and I will add it to my clean, dry beaker, and I will cut it into smaller pieces here, and then I will go ahead and add the nitric acid. Well, we have a very interesting container here, and all I have to do is squeeze the container and it will come up to 5 milliliters, and the procedure called for between 4 and 5 milliliters, therefore it's not a critical volume. So I will just pour it in here. Now let's watch this beaker as I pour it in here. And the reaction is quite vigorous, and when I feel the bottom of it, it's getting hot. It's getting hot. The bottom of the beaker, this reaction is hot. And I see a brown gas coming off of the copper as it's dissolving into the liquid, into that concentrated nitric acid. And I am going to swirl it to enhance the speed of the reaction, and you can see that all of it has dissolved now, but I need to make sure that all of that brown gas has come off of here, and the color of the liquid changes from green, and then it's going to get a very beautiful royal blue. And I need to make sure that before I remove it from the hood that all of that brown gas has come off, and that is NO2, and that's in our very first reaction. Wasn't that exciting? That's so wonderful. Well, now we're going to take this and add some other things to it, and I will see you at the lab station. Well, here we are at the lab station. I have my solution that I have produced in step 1. Now I'm going on and I am going to add 100 milliliters of distilled water. And I always like to use distilled water whenever I'm doing a lab because I do not want to get any contaminants in there. And even though we've said this many, many times, we never pour materials back into their containers. Never, ever. We never do that. So I need to make sure, oh, I wanted 100 milliliters. I'll get 100 milliliters here. Now it's very difficult to see where the 100 milliliters is if this thing is there. So I will remove it and then I will add my water. And that's pretty amazing. It's 100 milliliters of distilled water. And I am going to add that to my solution here. And you can see it's a beautiful, beautiful blue. Now the next part of what I'm going to do is add 30 milliliters of my sodium hydroxide, that's 3 molar. And I can squeeze these containers, and I'm going to need 30 milliliters, and this is only going to give me 25. So I need to actually use this graduated cylinder to get the 30 milliliters. And I'm going to look at the bottom of the meniscus is on the 30. Ooh, a little bit more. Now I have 30 milliliters in my graduated cylinder, and I'm going to add it to my solution. And as I add it, you can see what a beautiful reaction this is. It forms like a gel, a royal blue gel precipitate. And it's very, very interesting. And I can swirl it a little bit, but it seems to be mixed very, very well. Now I'm going to heat it on the Bunsen burner. And here's my Bunsen burner. And I'm going to go ahead and light my Bunsen burner. You know how excited I get? I'm so excited to light the Bunsen burner. Well, here we go. Get it some gas. Something's not right here. This tube is not hooked correctly. So, there, I fixed that. Now the gas is coming out. Ooh, got some flame going there. So here I go. I'm going to heat that until it gets right to the boiling point, and the solution, well, you'll see what's going to happen to the solution. Well, here we are looking at the beaker, and we can see that it is turning. There are black particles that are coming about there, and the copper 2 oxide is black, and therefore all of this copper 2 hydroxide will be changing to copper oxide. And we can see those black particles forming such a beautiful royal blue, and then it turns all black. And as soon as we have it all black, then we have finished as much as we need to do for today, and we will resume our lab tomorrow. So we'll just wait for it to become totally black. And I also, a word of warning, when you use a stirring rod, notice that there are particles on the stirring rod. Therefore, I'm going to have to keep this stirring rod in the solution, or else I'll lose my copper. And we're going to be graded on how much of the copper that we get back out. So we need to make sure that we keep this stirring rod here and not place it on the lab station. Because it has copper on it. We don't want to lose any of that copper. Now, when we're waiting sometimes, if we were actually in the lab, you could be working on some of the problems that are given in the lab while we're waiting. And as you can see here, this solution is getting darker and darker as more and more of the copper 2 hydroxide is forming copper 2 oxide. It's becoming darker and darker. It's a good sign. We like to see that. It's going as planned. Yes, sirree. Oh my, it's getting darker and darker. Now, it would have also been fine, actually, to let it sit overnight. It would have also turned black. But this lab is designed to do straight through in 2.5 hours, and therefore it would be necessary to heat it because you wouldn't have the time overnight. But we need to use the Bunsen burner. You know, I'm not going to eliminate that part. And there we have it. It's all black. And so I am finished for today. This is as far as we can get for today. And I'm going to go ahead and turn off this Bunsen burner, and I'm going to put this aside and have it wait for us for tomorrow. You can see that, oh my, we got some bubbles going on down there, and we must be cautious with that. Well, that was some fun, and we get to do this for 2 more days. I'm so excited. So I will see you tomorrow. Bye.